All right, guys, let's get started. My name is Akash Kapoor. Well, good morning, good afternoon, and good evening, whatever part of the world you are in. How I'm going to organize this session is I'm going to introduce myself, and then we are going to go through the case study of web analytics for e-commerce. Post that, I'll talk about what the employers look for when they're recruiting a data scientist. What this next would be, what this course gave me, and finally we'll go into the Q&A session. Right, so with that, again, my name is Akash Kapoor, and I have more than 2 decades of experience. My first interaction with BI and analytics was in 2006 when I was working in US. And during my master's, I wrote a thesis on impact of terrorism on tourism. That was the first interaction with SaaS as well as present-day data science. After that, since 2006, I had been into BI and analytics with different tools in different companies and different verticals. And presently, I am working as a senior manager BI and analytics at Agria Solutions, as you can see at the bottom of your screen. So now, without further delay, what I'm going to get into is the web analytics for e-commerce. So presently, e-commerce industry in India, or say the e-commerce market in India, is growing at 30% compounded annual growth, which is much higher than the global growth of 8 to 10%. Now, if you look at the graph at the bottom, just a second, I'm getting questions now, but hello, Bharti. Okay, so what I was saying is it's growing at 30% compounded annual growth rate, which is much higher than the global growth rate. Now, if you see in 2013, the growth was 55.6 because that's where it was actually coming up. Although the growth has slowed down a bit, but the total volume or the volume is increasing now. So we are still in 2017, the expected growth is 32% in the e-commerce market. And expected it is to be like $14.18 billion market in India. So still a lot of scope in this particular industry, e-commerce industry. What are the drivers which actually are driving this growth? So increasing broadband internet. So the growth is 20% month over month at this point. And as more and more people get connected, more people are going to go online to see what the products are. They can buy the products. Rising standards of living in a burgeoning, upwardly mobile middle class with high disposable income. So India has one of the biggest pool of middle class. Now with the higher income coming in, they have bigger pockets and they have much higher disposable income. Availability of much wider product range compared to what is available at the brick and mortar retailers. You go to Amazon, you go to Flipkart, you go to ShopClues. So any of these companies you go to, you can get wide range of products at one simple stop. Stop. If you go to brick and mortar, there you have to, for example, you go to a shop for shoes, it's just shoes. You have garment shop, you have the electronic shop. Here you get all of them in one go. Busy lifestyles, urban traffic congestion, and lack of time for offline shopping. So we have busy lifestyles. It could be like we get 15 minutes in the office and we know what product to buy. We go online, search, compare 2 or 3 sites, and then we kind of order it. Whereas if you have to go to a mall, it's the traffic congestions and the time taken. So people do not have time. So busy lifestyles, urban traffic congestion, and lack of time for offline shopping. Lower prices compared to brick and mortar. The operational cost at brick and mortar is much more than what it is for online. So that's another driver. Lower prices compared to brick and mortar retail driven by disintermediation and reduced inventory and real estate costs. So the operational cost is more, that's what I said in the beginning. Increased usage of online classified sites with more consumers buying and selling secondhand goods. So sites like Quicker, OLX, they have the secondhand goods as well. Again, it's an e-commerce. May not be for the fresh goods, for the secondhand goods. So that's again increasing. Evolution of online marketplaces, place models like Jabong, Flipkart, Snapdeal, ShopClues. So this is from Indian perspective, I'm telling. These are some companies which have come up. Amazon is here as well, which is doing really good. The government is also focusing on promoting e-commerce, innovation, and entrepreneurship. So these are the key drivers for growth in India. Besides that, now we have, earlier it used to be market basket analysis and those kind of stuffs. Now for an individual user, you can actually go for the recommendations. If you, whenever you buy something on Amazon or Flipkart, you'll see at the bottom there are certain other products which are showing up, that these are the products you can, people who bought this also bought these products. So that's a recommendation engine which is based on individual's preference rather than a market basket analysis. So more work is being done on that. That's again data science behind the scene. And also with big data coming into picture, you can do it on the entire data, the analysis of the entire data, and come up with it. So these are some key drivers, I would say, for growth in India. Now this case study is on one of the e-commerce industries, ShopClues, and the case study actually talks about propensity of buying. The problem we are solving here is a propensity of buying. Now, little brief about the ShopClues. An online retail website headquartered in Gurgaon started its operations in year 2011, and they had been doing really good year over year. Sell lesser known or unbranded items online. So that's the USP for this particular company. Lesser known or unbranded items online positions itself as a marketplace for smaller city buyers and sellers. So the goods what you get at markets like Janpads or Sarojini Nagars, you get here in this particular website. So it's not about the branded ones, because you can get those at Amazon's, Flipkart's. So their USP is they get non-branded items and they can sell it. They are actually doing pretty good on that. Unlike other marketplaces which tend to focus on mobile, electronics, computers, and branded fashion, ShopClues focuses on unstructured categories which contribute to 2/3 of its revenue. Although they do have mobiles, electronics, computers, and other stuff as well. But the major revenue, you'll see the kind of items what you get at ShopClues and the throwaway prices what you get here, you won't get at Amazon and Flipkart's. It was the first company to launch India's first wholesale marketplace. So it has a wholesale marketplace, the first one to launch that. Now for the study, for the marketplace, the propensity of buying study, we had the data sources, two sources of data, online data residing on the cloud and the data warehouse. The online data is available post October 2014, as the company has implemented Omnichannel 2014 only. In 2014 only, Google Analytics provides data on macro level and not on user ID level. So they had Google Analytics, but it was at a macro level, not at individual user ID level. So what we took, what data was taken here was the data residing on the cloud, which was the Omnichannel cloud, and data from the data warehouse, their regular data which they had. So few of the observations from the data. During categorization, it is observed that data is very noisy. There were duplicate records, and so several data was missing. 70% of the transactions have no user IDs as they log in as guests. So even today, I would say people still log in as guests whenever they want to buy something. So when you log in register into a website, a user ID is created. So from this data, what we found out was it's just 30% of the buyers who actually register on the site. 70% of them just actually buy it as a guest. They don't want to register on the website. So our target was the users who are actually registering on the website, who have a unique user ID. So that was another observation, and our target was, the population was the people who have registered on the website, who have user ID. Demographic variables are not giving the correct information. So people generally do not give information if they are asked for, like the name they would put, they put their email ID, the phone number. If there are like gender and your income level, etc., those are generally not put in there, and those are not mandatory fields either. So we generally do not get data for that. Data is having a lot of multiple entries for the same variable at the same time. So deduping of customers and accounts as transactional systems usually do not provide safeguard to stop the generation of duplicate customer accounts. So we had to dedupe the data. So once we collected, the data was with 36 variables and 2,60,725 observations. This was the data which was collected. In fact, the variable numbers were more than 36. We'll get into that in a little while. The tools and techniques used for analyzing the data. Data was extracted from Omniture. Omniture is a web analytics tool from Adobe. Analysis was done in R and SAS environment. Visualization was done with the help of Tableau and Excel for this particular study. The data description and preparation. So in any of the data science project, if you divide it into 4 phases, first one is a collection of data, second one is a data preparation, third one is the model building and analysis, and the fourth one is the inference. Now in these 4 phases, the second phase of data preparation or manipulation is the one which takes 40 to 50% of the entire project time. So that is what happened with us as well. It took most of our time into data preparation because data, as was mentioned, was noisy, and we had to figure that out. Okay, I'll take the questions in the end. You can have your questions posted. I'm seeing some questions being posted though. I'll take those questions in the end. After examining past studies, observing the website and understanding all the metrics and dimensions that were captured in Omniture, following broad categories are identified: demographics, acquisition, transactional behavior, and outcomes. Now, I actually researched about what are the factors which influence propensity of buying, or what are the factors in the e-commerce industry. So the primary factors from different researchers, different papers, case studies, I came up with 4 categories: demographics, acquisition, transactional behavior, and outcome. Our dependent variable was orders, which was identified as a target variable. So orders was our dependent variable, which was in the outcome category. So these are the categories. These will be further bifurcated into variables. Demographic, user ID. So company assigns user ID to the users who register on the company website. The customers who buy and do not register are not captured in the study. So the ones which have some transaction were actually taken into account. Second was the location. This gives information as per geolocation at the time of order, which varies if a person is traveling and not the permanent location. So we had categorized it. Insights companies focusing on tier 2 and tier 3 cities but 66% of the revenue is generated from metros and tier 1 cities. Although the company is focusing on tier 2 and tier 3 cities because the goods are pretty cheap and would target lower income groups or the goods which are available, as I mentioned, in Janpaths or Sarojini Nagar markets, those kind of things. So gender, age, education, income, address of the users are not captured correctly in the database. These are not used. So this is just the analysis of what we captured and what was available to us, where we had data, we took that. In this particular case, user ID was the only available demographic which was reliable and which could be taken into account. Acquisition. So acquisition, we figured out that 99% of the users are browsing through different versions of Chrome. So the browsers could be Chrome, could be Firefox, IE. So thus this variable was dropped because it was heavily towards Chrome, pretty much all of them towards Chrome. I would say 99%. Campaigns again in the acquisition part, you have the campaigns. Like if there are some advertisements, people click on the advertisement and come to the website. For example, Yahoo billboard campaign, Shop Clues September 2014 campaign, China Bazaar campaign. So here you have ads placed for Shop Clues, and if a person is clicking on that ad and coming to the website, that's what campaign means. From Yahoo billboard campaign, we see the dark ones are not buy and the ones which bought are at the lighter color. Similarly for Shop Clue September 2014 and China Bazaar, we see most of the buying are happening through China Bazaar campaign. There were not many campaigns during this period, and this variable is also having a very few observations. Now the behavior. This was a very significant variable or a category which we figured out. So behavior, very significant category for the study, as the behavior on website combined with other categories provides a much better understanding of buying by customers relative to just studying the customer behavior. Now there were like 10 different variables for behavior category. Time spent on website. It captures the total time spent by the user in the duration of the study, which is from 10th November 2014 till 9th December 2014. Our data was for 1 month. The insights, what we see is for product view, there is a decreasing trend as the time increases. What that means is, say here we have product view, cart addition, and the orders. There could be people who are viewing the product, there could be cart additions, and finally when the order comes where the revenue is coming, less than 15 seconds, we see 4 million users actually going there. Less than 15 seconds, in this category, cart additions were little less than 50K. And the ones which actually spent less than 15 seconds, the orders were around like 40K. 15 to 29 seconds, we see the trend here again for orders. The trend increases for orders for 1 to 3 minutes. So people actually spending 1 to 3 minutes, we see like 100K people ordering. And then the trend decreases. People spending 3 to 5 minutes are less likely to order, and then this continue to decrease. For product view, we see maximum in less than 15 seconds. It's pretty much stable in the next two, and then increases a bit and then decreases. For cart additions, maximum is in the less than 15 seconds. So insights for product view, there is a decreasing trend as the time increases. Maximum orders took place when the time spent is between 1 to 3 minutes. it decreases as the time spent on the website increases. So what a company would be interested in are the orders. Where are we getting maximum orders? People who are spending 1 to 3 minutes are giving us more orders. That's what the data is telling us at this point. This is what we are doing right now, is the exploratory data analysis, EDA as it is called in the industry. Further, we'll actually develop a model on this and see what is coming out of it. Entry day of the week. The day of the week when the user visited the e-retail market. So what we see is on Sundays, we see maximum people, the product views, cart addition, orders. Orders are, of course, directly proportional to this revenue. And it could be the order number is less, the revenue is more. That's possible because it could be a person buying gold. The order is 1, but the value is more, so the revenue is more. So what we see is Sundays are the days when we see more people actually ordering, more people doing cart addition, more people doing product view, and more people doing revenues, more revenues being generated. Now this, what this tells us is, when we are at our leisure time on Sundays, or maybe some campaign goes on Sundays, because there is a flea market campaign on Sundays, that actually increases this. Other days we see relatively lesser orders than Sundays. Sundays being a holiday and leisure day, maximum product views, cart additions, and orders took place on this day. Monday is the second best day for orders, as the cart additions done on previous day are converted into orders. So there could be some cart additions which are, people are just ordering it now, whatever I actually selected, let me order that. Recency, the length of time that passes between visits from returning visitors. Now return frequency, 1 to 3 days, a person is returning in 1 to 3 days, 3 to 7 days, 7 to 14 days, and so on. What is the percentage of product views, cart addition, orders, and revenues? We see people who actually return in less than 1 day. That's the area where we get most orders, we get most revenue. The users visiting again within a day orders more than other users. As the time increases, the conversion percentage decreases. This can be attributed to someone who sees a product and wants to buy it, who generally comes sooner to buy it, and maybe after comparing with other sites. So we generally do it like that. We do go to one website, see what the product is, what the cost is, go to another site and the third site and see which site is giving me best price, and we go and do it. So the person who are really focused on that, they come in less than 1 day recent visit and are more likely to order it. That's what this exploratory data analysis is telling us. Loyalty, the length of time that passes between visits from returning visitors. A new customer, a return customer, and a loyal customer. New customers account for maximum orders, but return and loyal customers places orders directly. So what that means is, new customers, the product views, cart addition, orders, and revenues. Of course, whenever a new customer is coming up, maybe through a acquisition from a advertisement or coming directly to the website, the revenues are more. The returning customer or the loyal customer is very frequently coming in there. They straight away go and order it because they know this is what the thing is. Let me just go and order it straight away. I don't have to do for product views and so on. So that's what this graph tells us. Entry page of the website. So where are people entering from? What websites they're entering from? Maybe from the home, maybe from the cart contents, Sunday flea market, any search results, my account, mobiles and tablets. Around 26% of the page views are home page, which is way ahead of rest of the page views. It makes sense as most of the users log in would come to home page. Next is cart contents page, followed by the search results. Now here is an interesting fact about shop clues. In the e-commerce industry, the conversion rate is 2%. Average conversion rate in the industry is 2%, meaning 100 people coming to the website, visiting the website, only 2 people are going to buy any product. Rest 98 will just go see and go out. So the entire picture in this industry revolves about increasing the conversion rate. In e-commerce, the entire thing is to increase the conversion rate. In shop clues, it's better than the industry average of 2%. It is at 2.53% at present, or when this study was conducted. Orders is a response variable. That's, as I mentioned in the beginning, that's going to be a target variable. This variable captures the number of times a user orders during 1 month on a daily basis. Now, if you see this funnel, we had product views by 17 million people. We had cart additions by 2 million people. And we had orders by 435,000 people. So from product view till orders, that percentage is pretty less. But if you see how this funnel is going on, you see product view at the top, then you have the cart addition, and then it further goes down to orders. And at present, the total conversion rate, as I mentioned, for this is 2.53% for shop clues. Some more insights. Although we did not bifurcate it through the through the categories, but just more insights here. Among top 6 categories, fashion has the maximum orders. Fashion has the maximum orders, but jewelry and watches is generating maximum revenue as average cost per order is high. Because jewelry and watches, we see the revenues are high, orders may be less because of the value of that particular order. Shop clues also sells gold bricks. So you get buy 1 brick, although the order is 1, but maybe like 27 lakhs or something like that. So if we talk of the orders, we get maximum orders, I think fashion and home and kitchen, pretty much neck and neck. The rest of them, the orders are less. Revenue wise, jewelry and watches are the maximum, and then there are others which follow. So what we did was to figure out the propensity. We had the orders as the response variable, and we use logistic regression into this. So orders, if a person is ordering, gets a value 1, else a value of 0. So it is a dichotomous variable. And rest of the variables, what we have been talking about till now, were all fed into the model. The steps taken for actually building the model are here, although I'm not going to get into each of the steps. We'll talk on what the results came out of it, and then we'll work on it. So data integration, data profiling, dependent variable analysis, data treatment, derived variable creation, bivariate analysis. Bivariate analysis is just checking for the correlations. Fine classing, coarse classing, multicollinearity, sampling, testing versus training the data, logistic model, statistical analysis, the lift chart, and the validation. So what we are going to do is, we already went through the exploratory data analysis. In fact, we started with just a brief about the shop clues, and then we went to do what the data was. Just going through the data, it was noisy, and how many, around 70% did not have the user IDs. So okay, can you hear me now? Yes? Okay. All right. So in fact, there were 45 variables, although one of the slides said 36. So that was the reason I was saying I'll get into the exact numbers. 45 variables were selected in the model. Key variables are entry day, entry page, average time spent on website, average pages per visit, recency, loyalty, product views. So here is the odds ratio for each of them. How do we interpret the odds ratio? Monday, the likelihood of person buying is 41% more than rest of the days. 25% for Tuesdays, 24% for Wednesdays, 26% for Thursdays, and so on. And Sunday we see, as we saw in our exploratory data analysis, Sunday 77% more chances of a person buying or say placing an order. Similarly for entry page, when we see say 0.86, it's like 14% less chances of placing an order when the person is coming from a home page. 19% higher chances when the person is coming from Sunday flea market. Similarly, for search results, 20%, 27% for Sunday flea market. So that's how we interpret the odds ratio. Average time spent, out of these, what we see is 0.9. Although it's like 13767 to 1866 seconds. If a person is in that particular category, he's more likely to buy. Oops. Average pages per visit. If a person is visiting like 14 to 15 pages, pages is like you're going to home page, from there you go to subcategory, see some product, and then you go to another category, see some product, and so on. So based on that, it was the data told us that 16 to 19 pages is where there is more likelihood of buying. The odds ratio are more likelihood of buying than compared to others. Recency, if the recency frequency is more than 14 days, we have 11% more chances of buying. Loyalty, a new customer, returning customer, and the loyal customer, we see there are 100% more chances of buying, or 102% more chances of buying for a return customer. Loyal customer, 99% higher, 78% for a new customer. Similarly, for the cart additions and the product views, a person who has cart addition of 2, 35% chances of buying. Product views, we have similarly for product views, what are the chances of odds ratio of buying. Now further, our results, what our model, when we run the logistic model, these are the further interpretations what we got. AIC, SC, and -2 log L by itself does not mean anything. It is compared between the models. The one which is with the lower AIC, SC is actually taken into consideration as a model which is a good model. Secondly, on the likelihood ratios, this is the ratio where which says here the null hypothesis is that all of the coefficients are 0, and alternate hypothesis is at least one of them is not 0. So we are getting a p-value of 0.0 less than 0.001. We will reject the null hypothesis. The likelihood of chi-square is this, with a p-value of this tells p-value of less than 0.0001 tells us that our model as a whole fits significantly better than an empty model. Empty model is where you do not have any variable. So there are variable whose coefficients are not 0. That's what this model tells us. Person concordant. Person concordant is a pairs where when you compare the pairs, the one which you are actually trying to target, for example, we are going to target pairs which has orders. Orders meaning order has a value of 1, and order the one which you don't, which there is no order, the value is 0. So when you take a pair, the predictive value for a target variable or the one which is 1 should be more than 0. That's a person concordant, and the other one is a person discordant, where the value of no order is more than the value of order, right? So mean predicted value is what I'm talking about. So what we got was 81.7% is where what we look for, which is actually a good one. We have so many pairs analyzed. You see at the bottom, 1 stands 100,000, 10,000. It was 8 billion. 8.25 billion pairs which were actually checked for, and we got 81.7% concordant, which is actually again telling us it was a good model. This is where what actually model fit is fine. We saw odds ratio, we saw the likelihood ratio, we saw the percent concordant. Now this is where actually our inference comes out. Now when we say inference, here inference comes out as, here is what industry is interested in. What we see here is, this is from the test model and this is from the validation model. So this training model, what we see by the fifth decile, if we go up, it is somewhere here. What that tells us is, now this is the blue line is cumulative percentage of expected and cumulative percentage of predicted. So if we do not use any model, the blue line is what is coming out, and if we use a predictive model, it's the red line, which is actually showing the lift. Now the graphical representation of the cumulative distribution function of empirical probability distribution, the lift of the predicted model and the straight line shows the cumulative percentage of the expected events. By the fifth decile, the model shows a lift of 22%. By the fifth decile, the model shows a lift of 22%, which implies that compared to a random model, a new model will capture 72% of the customers buying the product in first 50% of the population, right? What that means is, your 50%, the top 50% of your population is contributing towards 72% of the orders. Top 50% of the population is contributing towards 72% of the orders, and the other half is contributing just 28%. That's what this graph tells us. Other left chart is the ROC curve. ROC curve shows how true positivity, shows high true positivity, which again shows that it's a good model. with an area under the curve as 0.93. Area under the curve measures the discrimination, that is also the ability of the model to correctly classify people who will buy and who will not buy. Also, both test and validation data are a false positivity is where the model is predicting the person is going to buy, but the person doesn't actually buy. So 0.93 true positivity, meaning we are actually identifying the people correctly. 93% of the people, population is identified correctly that the people who are going to buy, they are actually buying. That's what this chart tells us. And it also tells us that this is again a good model, right? So with this study, the conclusions were, based on the findings, it is seen that 72% of buying is done by 50% of the registered users. Shop clues should invest their marketing dollars on these customers to upsell and cross-sell their products. This will enhance companies' revenue and provide better ROI with optimum utilization of marketing resources. So when you are getting orders from just 72% of the orders from the 50% of the population, rest of the customers are contributing just 28% towards your revenue. So you will target to the above 50%. You will be able to upsell, cross-sell to these people because they are highly likely to buy. And by cross-selling and upselling to these people, you don't have to market too much. You do not have to provide too much incentives, thereby increasing your return on investment. So that was the conclusion of this study. There are other use cases like the churn prediction, or propensity of buying we just saw. Market basket analysis is again what you can do here with e-commerce. And there are several other in the industry, depending upon what vertical you want to target. It could be different from vertical to vertical. All right, so with that, I just wanted to get into a few more points what I talked about in the beginning as to what employers actually look for when you say, when you're going for a data science interview. So primarily, if you already have experience in data science or some projects into data science, they would look into what approach you took while actually resolving a case study. That is one. Second, some knowledge of SQL, structured query language. Third is about the statistics. You should have good hold on statistics, because if you're using some statistics, like in this case, I use logistic regression, you could be using decision tree, linear regression, or some other decision or some other techniques. So you should have good hold on that. If you're asked how this model is good or how this model is bad, you should be able to answer. So that's what is checked again. And of course, on the soft skill, you should be articulative enough, because a data scientist is going to collect the data, then modify or say manipulate the data or prepare the data, prepare a model, and after that, the person is going to give a story, articulate it as to what is coming up. So good communication skills are another one. Having said that, from this course at Great Learning, I had some background during my Masters of Statistics. So this actually helped me with recalling those things which had gone on cold tray. Second, the major part was Here you have the industry connect. I actually compared one of the courses in IIMs with this course, and what I figured out was it was more of the theory piece. And here, when you see the industry connect, industry people coming into the campus and letting us know how do they uh, use statistics or data science in their field, that helps. Plus, it also provides you an opportunity network where you can network with people. Now I have few network with people in the industry that again I got from the Great Lakes. So these are a few of the benefits what I got from this course and which I'm actually utilizing right now in my job as well. All right, guys, with that, we will come to the end of our presentation. Thank you. It was pleasure actually interacting with all of you. I wish you luck with your next future endeavor. All right, now I'm signing off. Thank you.